Hi, I'm Whitney Lee, and I'm here with Anthony Baker, and Anthony's going to teach me and you today about GemFire. Tell us about yourself.
Thanks, Whitney. I'm really glad to be here with you and excited to talk about GemFire. Again, my name is Anthony Baker, and I'm the product lead for GemFire. I've been working on GemFire for, I would say, over 10 years now, both, from the ground up as an engineer, engineering director, and now as product lead. And
Wow.
I really enjoy the product and the technology, but mainly the users and their stories. That's really what draws me in and keeps me excited about GemFire.
Cool. So you know like one or maybe five things about GemFire that you're going to tell us about.
I hope so, yeah.
As I'm a relatively new learner, and one thing I love to know getting started in these types of conversations is what was the world like before your technology, GemFire, existed that caused it to get built? Paint me a picture of the context first.
Okay. And
Okay.
this should be fun. It's always hard to know how far back to go because
Okay.
databases and data has been around since the beginning of computers, right?
Uh-huh.
I like to think like, everyone loves to focus on applications, but applications without data is kind of meaningless. So to
Yes.
me, the data matters a lot. And when we think about GemFire, there was a previous product that was built in Smalltalk. It was called Gemstone Smalltalk. That was an object
Oh,
database.
already you lost me. What's small talk?
Okay. Smalltalk is like um, it's a object-oriented programming language that no one uses anymore. Now, I'll
Okay.
say that and I'll be wrong, but that's true for the most part. So
Yeah.
it was one of the languages driving object-oriented programming back in the day, but it
Okay.
kind of died off when Java came around, which
Gotcha.
everyone in the Smalltalk community is bitter about. But um, the point here is that there was a database. It ran on a
Uh-huh.
single node, and it was used for really interesting systems like running container ships and banking systems. And there was a major market event that caused excess loads everywhere in all systems. Servers were melting down, and the company that was building that database at the time found from that event the genesis of GemFire, which was to take that Smalltalk product, write it in
Uh-huh.
Java, and make it a distributed system that could scale dynamically on demand.
So what I'm hearing is before GemFire, it was common for databases to run on a single computer.
Yeah. And I would say, that's still the default today. We have a lot of database choices out there, but
Uh-huh.
if I think of Postgres or MySQL or Oracle, like that's the basic idea. I'm running on a single node. I mean, it
Okay.
may now be virtualized, it may be in the cloud, but it's still like there's some amazing database technology, but it runs on a single node. And
Okay.
that's where GemFire comes in because we can scale out to dynamically handle loads that spike and grow over time.
So GemFire, it sounds like, is distributed. And so what problems does that solve specifically? So with a single node, you have one point of failure, but is it also performance related to have it distributed?
There's a few different ideas. So one is, yes, because it's distributed,
Mm-hmm.
resiliency and failover is built into our DNA. Um,
Mm-hmm.
the second idea is that GemFire is an in-memory system, so we store our data in memory, and that
Oh,
allows us to operate much more efficiently
okay.
than reading and writing from disk. Even in the age of persistent memory or solid-state drives,
Mm-hmm.
memory is still significantly faster. And then
So
alongside that, we can implement different strategies for avoiding locking and things like that. So,
you're getting ahead of me just a little
okay.
bit.
All right.
Okay, let's slow down and focus on before GemFire, the problem space we're entering is that there was generally just the database just ran on a single node or a single computer. And so now we have GemFire coming into the picture that is distributed, but also offers other benefits that you're starting to get into, which is great. But is there anything we want to say, any more we want to say about before GemFire, before we move into what is GemFire?
Well, I think that kind of sets the context for us.
Okay.
There's a, I guess there's a lot to talk about when we think about the difference between running on a single node and being in a distributed system and having all of that compute power available to us. And that's one of the key things we'll go into today.
Excellent. So now let's get like a blanket definition for like what is GemFire, and then we can dig into the nuances of what each thing is. Does that sound okay?
Yes.
Okay.
The funny thing is, that's a really hard question to answer. And
Yeah.
I've heard various people take this on over time because in the beginning there was a category of product that I think we fit nicely into, and it was called the in-memory data grid space.
Okay.
However, we've added features and capabilities over time, and I don't think that label is necessarily the best way to segment the GemFire product these days. So what I would call it is an in-memory database.
Okay, a distributed in-memory database?
Distributed in-memory database, and our focus is on low latency, real-time transactional workloads.
Oh, you're going to have to repeat that for sure.
Exactly.
Okay, focused on. Okay, what are those?
Let's just call it low latency, because I think that is the key idea here. Is there's a lot of databases that even are distributed these days, but how many of them can give you low latency results in a predictable way? That's a kind of what our design center is.
Excellent. So now I have a good framework to have the rest of this conversation, and I'll let you drive a little more than I was currently. So from here, what would you like to teach us all about GemFire?
Okay. Well, I think, as I mentioned earlier, one of the things I love about GemFire is that it matters to people, and not just to developers, but to people in their everyday lives. And this is something that I've always found valuable, is like, my work matters and has an impact. And so let me just walk through a few ideas here. So I don't know about you, but last night I was at the grocery store and I used my credit card. When I made that purchase, that went through a GemFire system that does fraud detection. So every time you use your credit card, it has to be authorized, and they do a risk profile. Sometimes credit cards get declined, but that risk system matters a lot, because you and I want our purchases to be valid and not show up in our bank account as someone else's, right? So that's a big deal. If I were to go to India or China and buy a railway ticket, that system is using GemFire. And those are really hard tickets to come by sometimes. So there's this huge peak loads once they release a certain number of tickets on a train. And so GemFire, this is another one of the qualities it provides, is consistency and transactional support. So if you're buying a ticket, you don't have to worry that someone else also has that ticket because of lagging eventual consistency or other things like that.
So something like buying railway tickets or using a credit card at a grocery store, right?
Right.
And will you again be specific about what GemFire is adding to these transactions?
Sure. So in the case of, let me give you a third example, which is when you make a phone call on certain carrier networks, one of the first things they do is they have to check and see if your phone is authorized to make that call, if you have credit in your account, things like that, right? Because if
Mm-hmm.
if you don't, they will deny the call. And so there's two things that have to happen is we have to respond in a low latency way because there's a certain period of time that is allowed for that call to be routed through. And if we fail to hit that guaranteed response time, then the carrier just authorizes the call, and then they're at risk for potential financial impact. So that's an interesting case where GemFire is part of the authorization system, and so it's storing the data that allows someone to write an application to make these yes/no choices.
So we're storing the data in a low latency way, and GemFire is there to be able to provide that speed and accessibility.
Correct. Yeah.
Cool.
Yeah. And I'll give you one more example, which is financial systems, from trading systems, lending, banking, insurance, foreign exchange. All of these systems use GemFire at their core. I think at one time or another, we've been in every major investment trading firm. And
amazing.
So to me, it's like if I were to go around and turn off every GemFire server in the world, something really bad would happen. And that's interesting because it's all behind the scenes. And like, well, you may not know GemFire is running. It's usually running at the core of a business where there's financial impact if it goes down or is unable to service requests.
So it's trusted by large, ubiquitous enterprises, technologies.
Yeah, for sure.
Enterprises. I'll put enterprises.
It makes working on GemFire really fun because there is an impact, right? But it's also a little scary, right? We have to be reliable. Otherwise, I don't want to get a call that says planes aren't flying because GemFire is not running.
I like the word reliable, in a reliable and low latency way. So for use cases, we talked about buying railway tickets in India or using credit cards at a grocery store or making a phone call. You also talked about financial institution transactions. So with all of these are backed by GemFire, and with GemFire, what it brings to the table in these transactions is that it responds in a reliable and low latency way. You can get your data quickly and and reliably. And then GemFire provides that speed and that accessibility.
Yeah, you got it.
Cool.
So, and the interesting thing about this is like you ask, what is GemFire? And some people have said, well, GemFire is a cache, and that's true. But there's also other things beyond that, because when I think of a cache, I'm like, oh, sure, I can throw that away. Like my browser cache, I can throw it away and it still works, right? The thing about how people use GemFire is even when it's only a cache, if you throw GemFire away, you may not be able to scale your front website to handle the load. Things won't work anymore. So even if it's not the source of truth for your data, you can't access that data in a performant enough way to handle like the digital enterprise use case. Like if I have my Citibank bank account here and access it on my phone, like, is the mainframe going to be able to handle that mobile application? I don't think so. And even if it could, it'd be so expensive that it would be cost prohibitive to make that happen. And then we'd be stuck going to the bank again. Like, who wants to do that?
I see. So the data is likely permanently stored somewhere else, and GemFire provides a layer between the permanent storage and the end user that can scale quickly.
So let's go back to that definition, because I called it an in-memory database, and there's various levels we can go through here. So like the first level we could talk about is look-aside caching. And that is basically the idea is the the data is stored somewhere else. I go fetch it. I squirrel it away so I can get it fast again. Right.
Okay.
And then the second level, and we'll get into maybe some pictures and details later, but the second level is inline caching, where I make a request to GemFire and we say, oh, we don't have that data. Let me go out to the source of truth, like a database or a mainframe, get it. I'll fetch it automatically, store it, and now I have scaled my reads out so that I can handle that load. I can also write directly into GemFire, excuse me, and have that update that source of truth like a database. So we can broker writes and do both read through and read through right behind caching to batch things. But then, like on top of that, so we've started with look-aside. We go to inline caching.
Those syllables that you're saying, look-aside, I don't know what that is.
Yeah.
Can you help me visualize?
That was coined a few years back. At least that's the first time I heard about it. And it was in conjunction with the idea that every microservice needs a cache. And depending upon the sophistication of that cache, you may just have to have like two different request paths, one that goes directly to your source of data and then one that goes to your cache. Okay. So I view that as like some of the more popular look-aside caches would be like memcache, and that's all it is. It's a cache of data.
Will you spell look-aside?
Look, like L-O-O-K, and then aside. So it's like next to your application.
I got it.
Yeah. I was sorry about that.
I was so clueless. I was like, in my mind, it was Luca-ci, like a, like,
okay.
I had no idea what you're saying. Okay,
all right,
so
we got that now.
would you like me to capture these different ways of using GemFire, or do you feel like that's going to come later? Do you want me to, by capture, I mean write down?
Yeah. Well, let's just go through a couple more since we're already here, and then we'll come back to the ideas in a minute. But so we talked about look-aside, then there's inline caching, which is like the automatic way of pulling data into your cache.
Hold on, please. So we're talking about ways to use GemFire right now, correct?
Yeah, but it's kind of related to the idea of use cases as well.
Okay. I should capitalize it.
Yeah, and I'm gonna share a secret of GemFire. The F is always capitalized in GemFire.
Oh,
and that's like one of the most important things, right?
Yeah. All right.
I always have to add this to my my spell checker.
I need a lightboard spell checker. That would be good. So, okay, so we have look aside. And then what was the second one you said, please?
Inline caching.
Okay. Inline caching. Excellent.
Cool. And we'll come back to these in a bit. And then the third thing that people use GemFire for is as the source of truth for your data. So that's when I'm like, I struggle with calling GemFire a cache, because when people are using it as a source of truth and there's no other place you can go to get the data, that's not really a cache anymore, right?
Right. Yeah.
I mean, GemFire goes away, there goes your data. So,
yeah.
Then there's a couple other things we can talk more about, is like the idea of a compute grid, where I have, I have 100 servers, and I'm distributing my computations across that grid. And the fifth one would be real-time decision making using events. So I think as we look at the NoSQL or non-relational database market, sometimes it's hard to pigeonhole products into one thing or the other. And so I want to make sure people have an understanding like how GemFire fits into the overall space and like all the things you can do with it, because it's pretty neat.
It seems pretty versatile.
Okay, so let's start to talk about like the ins, or maybe the behind the scenes look at GemFire, because I think that will help us get a sense for how you use it and what you can do. So
Okay.
the first idea is that we're storing data in GemFire, of course, but we're
Mm-hmm.
storing it as keys and values, right? And
Okay.
so typically we talk about put and get operations. So put is, go
I have
ahead.
a quick question.
Yeah.
Is data always stored in GemFire as a key of value, or is that for this particular use case that you're describing now?
It's always stored as a key and a value. Now,
Okay.
that's where it gets interesting because, well, what's
Uh-huh.
a key and what's a value? And
Uh,
you get to decide what you want to store. So some
okay.
databases, everything is a string. Sometimes in a relational database, it's tabular format.
Uh-huh.
GemFire is a key value store, and
Okay.
can be used for document use cases as well, like JSON based, but
Mm-hmm.
everything is a key and a value.
Okay. Thank you.
And one of the important things to grasp here is GemFire is written in Java.
Mm-hmm.
And the typical pattern is that keys and values are Java objects. Of
Okay.
course, you can access it using many different kinds of language clients like C++ or .NET or whatever, but
Mm-hmm.
usually the keys and values are objects. So I may choose, let's take the case of a pharmacy. So you go to your
Mm-hmm.
pharmacy, they have GemFire on the back end. They want to look you up by, say, your member ID. So that's your key. And then they have a lot of data about you, your benefits, your prescriptions, etc. All of those
Mm-hmm.
can be values, and you create rich objects that have lots of fields and values in them. And unlike a relational database, it's a
Mm-hmm.
schemaless environment. So you can choose how your values are stored, and you can change that over time.
So the key values are Java objects, and it's schemaless. Excellent.
Yeah. So, and that's so that's the basic idea is we start out with storing keys and values. And those values are some type of object that you get to define for your domain. So if it's insurance, you probably have a claim object somewhere in your system, and you probably have several billion of those that you want to store
Mm-hmm.
in GemFire. And so in a relational database, I have a thing called a table that I put data into, right? And I
Uh-huh.
have columns in that table that I define. So in
Mm-hmm.
GemFire, you have a region that's like a table. And then
Okay.
inside that region, I store keys and values. And like the fields in a database would be the
Mm-hmm.
fields in your value object. Does that make sense?
The fields in your yes. So, well, the table is the key, and and then the values are the columns.
Yeah. So if I were to talk about it in database terms, the primary
Uh-huh.
key is the same idea as the key in GemFire. And I
Okay.
may have like composite key with different fields and things in it, right?
Got it.
And then
Mm-hmm.
the other columns would be the value.
Okay. I got it. Do you want me to
Cool.
draw that out?
All right.
Yeah. Should I? Shall I? Or
Um,
I? Yeah. I need your judgment about if this is enough space. If I
I
should keep
think
drawing or.
you should write smaller.
Okay.
Um,
Okay.
so
You keep talking. I'm gonna make this smaller while we.
okay, cool.
Yeah.
So when we talk about so storing keys and values, in
Mm-hmm.
fact, there's a data structure in Java called the hash map, which is kind of
Mm-hmm.
exactly what this is. It allows you to specify a key and a value, and you you have put and get operations on it. So it looks very much like a hash map. The thing that you get that you need with caching, though, you need extra behaviors attached to that storage in our region. So the first thing, I don't know if you've heard the old joke about the three hardest problems in computer science. The first one is cache invalidation. The second one is off by one errors. And I don't remember what the third one is. But so especially when we talk about caching and in-memory data, how long is that data around for? You only have a finite amount of memory. So we add eviction and expiration behaviors to data so that somebody may only need 1 day's worth of trades in their system for doing an investment management or risk management product. So they expire data and manage the size of their working set.
Eviction and expiry.
Yep.
Nice.
Cool. And then another thing we've added would be listeners for data events. And this is where, like we were talking about inline caching before. So you can register a listener. So anytime a record is added, updated, deleted, and then you can fire behaviors on those events. So that's how I can write a listener that talks to my database or to Kafka or whatever other integration product you want to use.
Cool.
But so far we started talking about distributed systems, right? And we haven't gotten there yet. So this is where it gets really fun because, okay, we've stored a key and a value. Now what? Well, that key and a value perfect. I love that you're drawing an array here. This is what I had hoped you were going to do this because that's exactly how I think about it, right?
Okay. I was just trying to capture, so like this is the primary key.
Yep.
And then the rest of this is the value.
Yeah, totally.
I don't know if it's big enough, but I just wanted in this to capture that around here.
Yeah. So imagine that table then lives on, let's say we have a system with two servers. That table lives on server 1 and on server 2.
Okay. So like it's replicated onto 2?
Yeah. And that is one of the key characteristics of GemFire is that let's say we have a client, it connects to server 1 and it says, I'm writing a new record with a key and a value. So that's like the first thing that happens. The second thing that happens is that server 1 says, okay, here's a new piece of information. I know that server 2 is also in my distributed system. So I'm going to tell server 2 about that data.
Okay.
Server 2 says, thanks for the information. I got it and I stored it. At that time, server 1 goes back to the client and says, your update is good to go.
I have questions.
I hope so.
So does it always go to server 1 and that server 1 updates to server 2, or could it go to server 2 first? Is there like a leader?
Yes, good question. I want to defer that question just a little bit because the answers is it depends. In general, GemFire is not a leader follower system. It's everyone are peers in the distributed system. But we're going to get into that a little bit more.
Okay. And I have a second question.
Yeah, go ahead.
When it's duplicated, you use the example of 2 of these on 2 different servers. two tables on two servers, is it always twice or could it be duplicated many, many times?
Okay, so let's go ahead and get into this because
Okay.
no one runs two GemFire servers. They
Okay.
run lots and lots of servers typically. So
Okay.
there are two kinds of regions in GemFire. So remember, a region is like the table, and
Uh-huh.
then the types of regions store the kind of replication that happens. So the first type of region is a replicated region. And that means the same data exists on every server in the cluster.
Okay. Can I fit the regions in this space? Are there a lot of different types?
There's two.
Okay.
There's more than two, but I'm only going to tell you about two because those are the ones that matter.
Okay. So the types of regions, and I'm going to go ahead and pull this, make a connection.
Nice.
Here. Cool. So the types of regions, and what was the first type, please?
The first type is replicated.
Replicated. Okay.
Okay. And so the idea with a replicated region is everyone has the same information. So this is great if I have some slowly changing data. Like, let's imagine I'm selling products and my product catalog changes like once a month.
When you say everyone, you mean every server?
Yes, thank you.
Okay.
Every server.
Okay, sorry to interrupt. Please go on.
No, it's fine. And sometimes I'll use the words like server or member interchangeably, but basically we have a cluster of servers all working together. And so in a replicated region, every server has the same information. So for slowly changing data, this is great because reads scale like mad because every server can answer the question of like, what's the data? However, writes are expensive because every write has to go to every member. And to go back to our client example of like the client does an update and then it gets replicated, GemFire does synchronous replication of changes. So we don't answer the client until we're sure that the data exists in the redundancy constraints that we've set up.
Okay. That makes sense if you're doing financial transactions.
Right.
The types of transactions.
Consistency model where, the client does an update and the server says, yeah, we got that. And then we don't really have that. Like,
yeah.
Obviously there are systems out there that work, but the client has to do more work to account for that potential data issue. So,
okay.
All right. And we'll dive into what this means for availability in a minute. But let's go back to the second type of region, which is a partitioned region.
Partitioned. Got it.
Yeah. And this is the sort of bread and butter GemFire region. The replicated regions are often used for lookup tables or things like that, but there's usually like one or two massive data sets at a particular application. Maybe it's like members or customers or orders, and there could be terabytes of data. That's really expensive to store on a single server. It's expensive to update and replicate. So what we do is we partition the entire data set into these things called logical buckets. So let's say you have a terabyte of data and we divide that into, say, 100 buckets of information. And then that's kind of like a logical breakdown. And then we assign buckets to servers. And the only reason I bring this up because it's one of the things I find most interesting about GemFire is that logical assignment of buckets to servers. It's dynamic. So you were asking about primary and secondary previously. Well, there's usually a primary bucket where all the writes go to, And then we have secondary buckets that hold alternate copies of the data. You could
Okay.
have one extra copy, you could have two extra copies. It really depends on you.
Okay.
And where those are located, we don't know. It depends, right?
Okay.
It depends on your data balance. If you want to add a new node into the system, like you have 3 nodes and you want to scale to 4 nodes because your data is growing. So when you bring up that 4th server, there's no data on it. And then you tell GemFire, hey, there's a new server. And it'll say, okay, I will move bucket 5, 8, and 22 onto that server. Automatically reroute load. And that's all kind of done magically for you.
Nice.
If that 4th server then goes down and we
Uh-huh.
say, oops, we're missing redundancy on those buckets, we'll automatically create new buckets on servers, put data in them, and manage that for the user.
What if a primary bucket was on one of the servers that went down?
Great question. So then we go through a process of saying, okay, what are the secondary buckets available? And then one of them elects themselves as primary, and life continues on.
I have another question.
Please.
Will you tell me like a concrete like business use case for replicated and one for partitioned?
Yeah. So let's say I'm building an order processing system. So I know that I've got customers, I've got orders, and I've got my product catalog. So, and I'm pretty sure that the product catalog is a finite set of things, right? Like, unless you're Amazon, it's fairly limited. It doesn't change a lot. And even if it does, the rate of change is fairly slow. Whereas customers and orders are going like mad. And so those I want to scale out. So my product catalog, I'll make a replicated region because it's fast. And the orders and customers, I'll make a partition region because those have lots of growth in them. And all my operations are on a small set of data inside that bucket. So.
Excellent. That's a perfect answer. Thank you.
Cool. All right. So we briefly touched on this, but let's go back to the idea of consistency because it's kind of at the heart of why GemFire is cool to me. There was a theorem created a while back called the CAP theorem, CAP. And, some people have different opinions about the CAP theorem, whether it's real or not, but I think it's illustrative, I think, for our purposes, which is there are 3 things that happen in distributed systems. One is you can have consistency. Second is you can have availability, or the third is you can have network partitioning. And the trick with this theorem is you get to choose 2, but one of them has to be network partitioning because that always happens.
Yeah.
So it's maybe, I think a good way of segregating out different kinds of products. So products that support eventual consistency are usually in the availability side of the world, and products that have strong consistency are on the consistency side of the spectrum. And so GemFire sits on the consistency side. And then so the question is, well, does that mean GemFire is not available? And that's where it gets interesting because while we can't provide 100% availability, according to the dictates of this theorem, we can still, have real world behaviors that let us approach really good availability. And the key to that is our group membership system. So whenever a server is unresponsive, and there's a lot of reasons why a server could be unresponsive. You could be running like some massive backup job on the server. Go ahead.
Is this a good thing to capture the group membership system?
Yeah.
Down?
Let's do that.
Okay. And begin again. I'm sorry.
Sure. So when you launch a set of GemFire servers, they all talk
Mm-hmm.
to each other and form a cluster. And the basis of that is this group membership system. And
Mm-hmm.
I won't go into too many details here, even though it's really fun.
Mm-hmm.
But the
It is
idea
really
is,
fun.
um, every server knows who's in the cluster. And there's a set of protocols around failure detection that let us quickly decide if a member is unresponsive, if there's a network partition, and then take action. That action may be removing the that unresponsive server from the cluster, and that
Mm-hmm.
allows us to carry on with a highly consistent view of our data without getting
Mm-hmm.
stuck waiting for servers that are unresponsive. Does that make sense?
So in the group membership system, all of the servers know about each other. And if one's being unresponsive, what happens?
In that case, we'll do some operations that let us double check that server and say, are you really there? And if it's
Mm-hmm.
unresponsive and unresponsive and unresponsive, we're going to
Mm-hmm.
say, I'm sorry, you're not helping us. We're going to fence you off for a while. When you're better,
Mm-hmm.
we'll restore you back into the cluster and give you the current copy of the data.
So here's a question. Are they only finding out someone's unresponsive once that server is being called to produce data, or are they always pinging each other and checking on each other?
The answer is yes. Both things are true. And so when replication isn't happening as we think it should, we'll go
Uh-huh.
suspect that member and try to make them healthy. And
Okay.
at the same time, we're always in this like gossip-based protocol to check on the health of members.
Okay.
And I think of it as like that lets us have our cake and eat it too. We want the cake of
Mm-hmm.
consistency, but
Mm-hmm.
we don't want to pay the cost to availability. Like we need predictable low latency to handle things like those credit card transactions or buying railway tickets, right? So you have
Mm-hmm.
to have predictable low latency down in the microsecond level, and
Yeah.
we can't wait forever for a server to give us an answer.
So unhealthy members, what happens to them when they're identified as unhealthy?
They get fenced off from the rest of the
And so,
cluster.
and so this group membership system is the ticket to the low latency that GemFire provides.
Yeah, consistency with low latency. So those are the two
Oh,
things
both.
that
Okay.
we want,
Okay.
because that makes it easier for users to write applications if they can have
Uh-huh.
both things.
Yeah. Man, we live in such a different world than even like 10 years ago. Or yeah.
I know, it's fascinating. Like,
Yeah, the fact that we can expect a credit card transaction, which needs to be super secure and one-to-one, like we're like, that should have happened in 5 seconds. What's going on?
I
Yeah,
know,
not even 5 seconds, 5 milliseconds. Yeah.
right?
Okay, latency, TENCY. Okay. So the group membership system, a group of GemFire servers is called a cluster. I have a question. I imagine this varies wildly, but like, what's a typical cluster size?
So it does vary quite a bit.
Uh-huh.
At the low end of the scale, usually you'll have like 3 servers, and then we've had systems that scale up to hundreds of servers.
Okay.
But when you're at the high end of the scale, it's more
Uh-huh.
you you typically scale both vertically and horizontally. So you have servers
Okay.
hosting a
So,
terabyte of data
mm-hmm.
per server, which that gets really massive really quick.
Cool. So the consistency and low latency of GemFire is provided by this group membership system, where you have a cluster of servers that know about one another, and they're always talking to each other. both when a transaction is happening, but even just like regular health checks on one another. So any unhealthy ones are automatically fenced off.
Definitely.
Excellent.
So, and all of that is very cool. But it has value, back to the idea of a distributed system is like any one node going down doesn't bring down the rest of the cluster. Assuming you've sized it correctly, we can maintain high availability for your applications. But if we then want to zoom out a little bit, like what happens if your data center gets hit by a meteor or some other catastrophic event, right? There goes your cluster, right? Well, we are able to connect multiple clusters using this thing we call cross data center replication, or WAN technology. So, and I think that is one of the things I've seen customers really appreciate, is being able to connect two different GemFire clusters. And there's lots of different topologies, from like active passive or active active. And it doesn't necessarily need to be just two. Like I've seen some trading applications do a follow the sun model, where it'll go from like London to Tokyo to San Francisco to New York, like 24/7 kind of cycle.
And that's fun and colorfully named. So the cross data center replication, is that like a GemFire cluster that's literally duplicated into another region, or is that one cluster that's spanning across regions? And maybe I shouldn't use the word region since we already have it taken here. Like
no, that's a great question. Typically in a GemFire cluster, you'll have multiple regions, and then you can assign those regions to send their data to another cluster located in a different part of the world.
Okay.
So
it's geo-replicated. It's not spanning. Okay.
Yeah.
Okay. So yeah. So if you have here in Austin, Texas, where I am, if I have a GemFire cluster that has 5 servers and I want to use this replication model to make sure that data is all available in Japan, will Japan then exactly have my data model of 5 servers, exactly how I made it?
It doesn't have to be exactly the same topology, but it would have the same data as we send those events across the wire.
Okay. I'm leaving room here for my head. Sometimes I forget. Cool. How am I doing on board real estate?
I think we can fit it in, but it's going to be tight.
Okay, noted.
We'll leave a little circle there. So one more thing I'm going to bring in, and then we're going to flip over to more the API side of things. But the other capability of the server is not only like when I go back to that tabular picture you drew, like that data is stored in memory. But I can also say I want that data stored on disk, because otherwise I couldn't really call GemFire a database unless I could bring the entire cluster down and restore it from disk. So it has persistence of that data. And that data can be persisted. Like I could evict data so that it still has a reference in memory, but most of the value is stored on disk. And when I need that value, I can page it back in super quickly. So that same idea, like when we talk about cross data center replication, that's based on the idea that we queue up a bunch of events and then batch them and send them over. But that queue of data is maintained on disk, so that if the cluster crashes, we can bring it back up again and start replaying events from the persistent queue.
It doesn't have to be stored to disk. It just can be stored to disk, right?
Correct.
And
Yeah.
I imagine in the source of truth use case for
That's
GemFire, this
really
is an
important.
important
Yeah.
part. Cool. Make sure.
Okay. So let's talk a little bit about operations on data a bit, because we've talked about like the servers and the cluster and their capabilities, but like, well, what do I do with it? How do I do it? So there are basic data operations. I've mentioned like put and get before. Those are like the core APIs: put, get, remove. And then there's bulk versions of them. Like if I want to put a bunch of data into the cache at once, I can do it in a single operation. Another thing I can do is I can query the data using a query language called.
Sorry, I want to. So there's put and get, and what was the
put,
third
get,
one?
remove plus
Remove.
bulk operations. So like there's a put all, a get all, remove all.
Okay.
So,
Okay.
Super handy.
Yes. Okay. Right. And now move on, please.
Cool. The second thing I can do is I can do queries on the data. And it's a query language called OQL, which it's a standard that's been around for a while. It's very much like SQL, except it's for objects. And so the difference is, like with SQL, you reference like select star from customer where first name equals Jane, right? Where in OQL, you can do nested references like object.field. So I could say select star from customer where customer.name equals Jane. So it has very similar capabilities, but more powerful and expressive for objects.
I made an assumption and I want to verify that it's correct. Does OQL stand for Object Query Language?
It does.
Okay, great.
Yeah. Anyway, I won't go into more of that yet, but that's what it stands for. It's got many of the basic things you expect from SQL, with some support for aggregate operations, and joins on regions and things like that.
Okay.
But let's go on. Functions. Functions are a way. Okay, so let me go back to one of the ideas about distributed systems. And like I started in distributed systems a long time ago. So functions are kind of like near and dear to me. It's my favorite thing. But so with queries, what I do is I go off, look at a bunch of data in the cluster and pull it back to the client and work on it. And if it's a big result, that's a lot of data. It's not super efficient, especially when I'm talking about like a terabyte of customer data. Right? I may narrow that down with a query, but that still could be a lot. So with a function, what I can do is I can take the behavior to the data itself. So I write some code, I put it on the server, and that code operates on the server. And if we go back to that idea of a partitioned region, like I'm not just running one copy of that function. I'm running one copy of that function on every bucket. So let's say I have 100 buckets. Now I have 100 things doing my work for me, and they're providing a summarized result back to the client. It's way more efficient.
Is happening. So to put this in laywoman's terms, the processing is happening in the GemFire cluster, or yes. I could say server side, but in the GemFire cluster.
Yes, definitely.
All right.
Cool. All right. So that's transactions. I'm sorry. That's the cluster basic operations. We've talked about queries. We've talked about functions. Another one is transactions. So if you need to do atomic operations, let's say 3 puts and a remove, but they all need to happen together or not at all.
Mm-hmm.
That's when we apply a transaction.
Transactions are these types of things, the first line, but bundled together.
Yes, correct.
What are we calling these types of things?
Like basic cache operations.
Okay. Got it. How am I doing on space?
We're getting there.
Okay. Okay. Got it.
Okay, so I think it's useful now to talk about one of the things around transactions and queries that make GemFire fast. So when we look at a database node, everything happens on that single database node, right? So if I run a query across 5 tables, it's all can happen within that one process space. In GemFire, my data is spread across a massive cluster. So when I run a query, I need to run it everywhere. And if I want to join 2 tables that are everywhere, that's a lot of stuff.
Yeah.
And there are good tools for doing that kind of thing. Greenplum would be an example, like massively parallel query processing. GemFire takes the other tact of like, how can we make things fast? Back to our idea of predictable low latency for real-time decisions. So what we do is we allow the user to, or the developer in this case, to say these 2 entities should be accessed at the same time. So for example, your customer information and your orders, like logically, those are going to be updated in close proximity, right? So it makes sense to put both of those in the same data locality on the same server.
Okay.
So when we run our transactions, we do it on a single server, no communication to other nodes in the system. It makes it very fast because we can avoid network traffic. Same thing with queries. If we want to join your orders and your customer info, we do it on a single node, super fast, no extra traffic. So it's called data co-location. And we can, just like with many other NoSQL databases, it depends on how you define your key and you associate data together that says, make sure, this data lands on the same server.
Related data stored together.
Yes.
Even if they were created at totally different times, you can put them together.
Yep.
Yeah.
Sounds good. Okay. Couple other ideas I wanted to share. So as there's another way to query data. If you want to do full text search, we support Lucene indexing. So that makes it simple if you want to, like, say, how when you are typing in something in a field on a form and it automatically completes for you?
Yes.
Usually that's implemented using full text search. And so we can create an index on, say, a customer database. It makes it easy to look up things like if you're at the pharmacy and they can't find your one number and you give them a different thing and date of birth, and they can match all that stuff up. So we support Lucene indexing.
Lucene.
Lucene.
Okay. Let's do. Is this now like kind of like a MISC, like other stuff kind of area? Other cool things?
Yeah, I guess so. I kind of think they're all cool, but
well, yeah, and other cool things. Yeah, not the only cool things. Yeah,
for sure.
Other cool things. Very formal. Other cool things. So Lucene indexing, Lucene is my guess.
Yep, you got it.
Okay.
Yeah, so that's for full text searching. Makes it easy to have less formalized queries. Awesome. So the last client capability I wanted to talk about was this idea of continuous query.
Mm-hmm.
And continuous query is the idea that I can set up a query on the server, like give me all of the records, all of the updates that match order equals, I don't know, socks. So
Mm-hmm.
every time someone creates a new order for socks, I can
Mm-hmm.
send an event back to my application.
Yeah.
And so it's a really an event processing mechanism
Mm-hmm.
that can be super powerful for people. Um,
Yeah.
and there's just like with events or messaging systems, you
Mm-hmm.
can set up highly available queues of data, make them durable, so that if there is a failure either on the client or the server, you don't drop events, and we ensure that events are always delivered at least once. Sometimes
Mm-hmm.
during a failure, you may get it twice, but at least get it once.
I guess that's guaranteed delivery, right?
Yeah, and
Not
there's
only once. Yeah.
the exactly once one is subject to discussion, but
Uh-huh.
that's a different topic. So,
I have a question. You
yeah,
said this continuous querying is an event processing mechanism. Where's the processing part come in?
okay, perfect question. Because when I implement this in my application, what I
Uh-huh.
do is I write an event handler, and all of the events from the server are pushed back to the client, and then you get to choose what you do with those events.
Okay.
So,
Got you.
yeah.
Thank you. Guaranteed delivery. At least once.
There you go. All right.
Uh-huh.
So there's a couple other notes I think that are important when we talk about clients and applications,
Mm-hmm.
because while we can do great stuff on the server, the client has to work together with the server to do the optimum thing. And so um, our clients, I, th- I guess I would call them intelligent, because it's not just a matter of can I connect to the cluster? It's can I connect to the server or to the cluster in an optimal way? So
Mm-hmm.
um, one of the things the client does is it will ask the cluster for load balancing information so it can send requests to the appropriate server. So it's not just like a round robin, it actually has intelligence to know what servers have capacity and route requests to those servers.
And
I
I'm
love your creativity and finding space. This is awesome.
intelligent clients.
Yeah. Intelligent clients with load balancing.
Okay. And is this specific to load balancing, or are there other ways they're intelligent?
Yes, there are 3 ways they're intelligent.
Okay. I'm going to get a new orange marker because it'll give me a smaller tip.
So the first one is load balancing. And it will go off and ask for not only, so I'm not sure I mentioned this earlier, but let me just clarify. So the number of servers in a GemFire cluster is dynamic. So I can
Uh-huh.
add new servers and remove servers on the fly. And the
Okay.
clients will learn about those new servers through a discovery process. So it'll talk to the cluster and learn about new servers, learn about the load on those servers. And as servers go away, they'll get removed from the client as well. Okay, the second thing it does is what I call single hop routing.
Single app, APP,
Single hop as in HOP.
hop. Okay.
Um, and if we look at our partitioned region type, what we know is
Ah,
the data is not on every server. It's on a specific set of servers. Like it's in those buckets. Those buckets are assigned to servers.
Uh-huh.
And so if we were to just randomly go to a server and say, update key X, it may not have key X.
Yeah.
And so then it would have to go somewhere else in the cluster and update that value. And that works, but it's not super efficient. And when we're looking for low latency, we need to minimize network traffic. So all of the metadata about where data lives is pushed back to the clients. And as the cluster dynamically adjusts where data is, the client knows and gets that update as well. So single hop routing. And then the third one is local caching. So the client itself can choose to cache data. And so if the client already has a piece of information, it can answer that question for give me this data immediately without going over the network to the cluster. And then within the cluster, we can tell the client that data that you've got cached is no longer valid. We've changed it. And here's the new data. So it kind of can tie into that continuous querying mechanism. And like clients aren't part of the cluster, but they can act almost as if they have that cluster data. So it depends on your application and how you want to design it. But local caching can be super effective for low latency use cases.
Amazing.
It's fun. Yeah.
Yeah.
And we support, clients in different languages, Java, C++, .NET. Funny thing is we actually even have a Redis interface. So if you have existing Redis applications, you can connect them up to GemFire and have all of this like management capability we've talked about applied to Redis applications as well.
So they're stored in Java objects, but different languages are supported. Is that
correct? Yeah.
Okay.
Yeah. So we've defined a data format called PDX. I'm not exactly sure what PDX stands for. I think it could mean portable data exchange. It's also the airport code where I live. So
yeah.
I don't know. But basically, C++ and Java clients can store data in the PDX format and read each other's data. Like there's no worries about interoperability. And the fascinating thing about PDX is it can allow for easy schema migrations. So if you want to add a field, both the old and new versions of your application will still work. You won't lose any data. It's super efficient for querying. So like one of the biggest costs in an object store like GemFire is serialization, like pulling data from binary structure back into objects and storing it again. And when we query stuff, like we only need like maybe one field from an object. And so with using PDX, we can read right down into the bowels of the object, pull that info out, and it's a lot more efficient.
That makes a lot of sense. Would you say all of these are GemFire features, these things in pink boxes?
Yes. Okay. I think we've got that.
I'm going to label them as such. And I'm hoping, I'm loving talking to you and learning everything, but I'm also hoping that you don't have too much more for me just because I've run out of space.
No, I think we've hit most of the big ideas. Let's just maybe go back to some of the qualities of GemFire as a whole, which is maybe we've realized as we're talking here, like GemFire is a shared nothing architecture. So each member is independent and shares nothing like disks or anything. So it's easy, to set up on commodity hardware. Another thing that's important, consistency. I think
have we not written consistency down on this?
I think we did. I'm sure we did.
Okay.
So that's like another key aspect of the architecture. we already talked about predictable low latency, right?
Uh-huh.
And then I think the third idea here is resiliency everywhere. So whether we're talking about PDX, queues, WAN, another one is no downtime upgrades.
I'm sorry, I'm so into my arrows. Well, you said consistent. You said no. What was everywhere?
So resiliency everywhere.
Resiliency
So,
everywhere.
anything fails, GemFire should keep running. And usually, bad things happen in real life. And
They really do.
yeah, right. I mean, no matter, but in distributed systems, especially, things happen. Like, okay, the network goes down, or you run out of disk space, or your motherboard has a fault on it. Like, all of these things can happen. And the question is, how can we build our distributed database so that my users aren't impacted? And so, like, one of the biggest things is, like, how can I do upgrades without a maintenance window? Like, maintenance windows, they don't exist anymore. Like, I don't know about you, but I do my banking at like midnight. And if Saturday night at midnight is a maintenance window, that's really annoying. So I want to be able to upgrade GemFire with no downtime in a rolling upgrade fashion.
Consistency everywhere. Consistency. Cool.
Yeah. Cool. So, I mean, I didn't talk. This is really looking behind the scenes of GemFire but if we were to pull back a little, we could talk about, well, how do people actually operate GemFire? And I don't know if you need to write this down, but let me just share a few things. So going back to like the small talk days, like the first era of GemFire was people deploying GemFire on bare metal, writing scripts, whether it's, shell scripts or bash or puppet or whatever. Then the next era, people started virtualizing GemFire. And then they started running cool application platforms like Tanzu application service, where GemFire becomes like a self-managed platform. And that's been really successful because, all of that automation around rolling upgrades with no data loss, no downtime, that's kind of built into the platform. It's like super easy. And then the same idea is like we take those management ideas to Kubernetes with the GemFire operator and give you more ways to run that, whether it's in the hyperscalers or vSphere or wherever you want to run your Kubernetes data platform. So lots of ways to run GemFire, and we're continually working to make that operational story easier while improving the developer experience.
Excellent. So I think I'd like to recap everything you've taught me to make sure I got it all. Does that sound good?
That sounds good.
So before GemFire, it was common, and even now you said it's common for databases to run on a single computer. So this is a problem because it was a single point of failure. But also as systems got distributed, if you only have one computer, it's going to be slow for you to be able to access that data. So GemFire is many things, but the definition today is that it's a distributed in-memory database that's focused on low latency. So some examples would be buying railway tickets in India, using credit cards at a grocery store, making a phone call. All of these we expect to happen quickly, but we also expect for them to be consistent and secure. So reliable, we'll say. So GemFire is the backbone of how this is able to have the speed and the accessibility that we expect from these types of transactions. And it is used at large and ubiquitous enterprises. So if something happened and all GemFire went away, it might kick off the apocalypse.
Hopefully not.
So there's some ways to use GemFire. for look aside, which was something about getting the data and then keeping it closer from a source and keeping it closer to where it might be needed, but not in a permanent way. We talked about inline caching. We talked about using GemFire as your source of truth, and that happens if you store it to disk. You can use GemFire as a computer grid, and you can also use GemFire to do real-time decisions. And we talked about that here too with the continuous querying. So at its core, though, GemFire is a key value data store. And if you're looking at a region, which is this table-looking thing, the key is like the primary key, and then the value are the other columns in the table. And so this is called a region. And so GemFire is schemaless. It's up to you to define your schema. And the key values are Java objects, but with clients and stuff, different languages are also supported. It's not just Java. So in addition to the data store, you also have data expiry, you have eviction, and you have listeners for events. So there are different types of regions, and it's for different types of use cases. So you can have your data where, okay, let's back up and say a set of GemFire servers is called a cluster. So when we're talking about our different types of regions, we can either have every machine, every computer have every type of data, which would be the replicated model. Or you can partition it where the data is divided into buckets and dynamically assigned to servers. So every server has some of the data. And we talked about different use cases for each, or even what I loved about your example was that it was all within the same company where your catalog might want to be replicated because that's not going to change very much, where your customer orders and customer information might be partitioned because you want that to be able to scale. So then we talked about some of the mechanisms for how it works and the features. So we have the group membership system where the set of GemFire servers is a cluster and they all know about one another. And so if anyone's ever unhealthy, they get automatically fenced off. And that's seen both like they're always doing health checks on one another, but also they're if someone's slow giving back information, everybody knows about it. They're getting a side eye. So that's like at the core of how GemFire provides consistency and low latency and resiliency. So then we have cross data center replication. So that's how clusters can be replicated across geographical regions, which is important. And we talked about GemFire being stored to disk. It as an option, it doesn't have to be, but if you want that functionality, if you want GemFire to be your source of truth, you probably want to do that. GemFire can perform all kinds of operations on data. So basic cache operations like put, get, remove, and bulk operations. It can do queries on data with an object query language, which is like SQL, but it has more features. GemFire can do functions where the processing on the data is happening in the GemFire cluster, which has two advantages. The processing is happening closer to the data, and also it's better because the GemFire cluster is distributed, so you have more compute. Lots of different computers can be doing the processing at once, so efficient on a couple levels. And then the transactions are basic cache operations can be bundled together, so that's something else you can do with GemFire operations. GemFire can also co-locate data so that related data can be stored together. And we use customer profile and customer orders wanting to be together as an example. And then a couple other cool things. It does leucine indexing, which is behind auto fill-in forms. It can do continuous querying, which is how the mechanism behind how it can work in a real-time way. So it has guaranteed delivery for events. And then GemFire also has intelligent clients. So consuming the GemFire data, the load balancing, it does that in a smart way. It does single hop routing. So if it goes to one computer, one in the cluster, and that computer doesn't have the data, that computer knows where to send it to where the data exactly is. And so only one little hop. And then it does local caching with current data. So the client will cache the GemFire data, but also GemFire knows whether that cache has the most current data and will update it. And yeah, that's everything we talked about. We also went on about share nothing architecture, rolling upgrades, resiliency everywhere, consistency. And I think that's it. Is there anything I missed?
I don't think so. I think you're an expert now.
I am. I'll switch over to your team next.
All right. I love that. But I guess I have a question for you, which is like, knowing all this, like, is there a gap? Like, do you have a question in your mind about like, well, what about this about GemFire?
Oh, I don't, because I've been asking everything along the way.
Okay.
I haven't been shy at all. I could ask, well, I don't know a lot about the space, but like I'd be interested in like what GemFire is offering related to other, like what are technologies related to GemFire and what differentiates GemFire like in the larger context of database space?
Yeah, that's a great question because like I remember working on a presentation a few years back, and there's this great picture, and the title, the picture was a guy sitting in a street with a sink in the rain, and
Uh-huh.
the caption was, "It's raining databases in the cloud." And
Uh-huh.
the fun thing about the last 10 years is like we've gone beyond the relational database market. There's like this all non-relational or NoSQL market. We're now running databases in the cloud. And so there's a lot of opportunity and space for databases that offer all of these things like GemFire to
Mm-hmm.
succeed in different ways. And each database has their own spin and unique design center. I think that
Mm-hmm.
the trouble is we don't have a lot of good words to really get into the characteristics. Like we talked a lot about consistency and group membership. Um,
Mm-hmm.
that really plays out um, on like Saturday night at 2 a.m. when something goes wrong. It's really
Uh-huh.
hard to put into like a marketing slide because everybody has the same check boxes. Yes, we handle
Yeah.
network partitioning, but
Uh-huh.
to do it in a way that makes it so you don't have that call at 2 a.m. in the morning. I think that's
Mm-hmm.
the key idea. So
Cool.
I like working on GemFire. It's fun for me, and I'm grateful that I get to do that.
Yeah, your passion is evidence. And this has been this has been an absolute pleasure doing this with you today. Thank you so much for this.
Yeah, thank you for your time and letting me open the curtain here. So thank you.
Yeah. Goodbye. Thanks everyone who watched.
Thank you.